Welcome to Weathered Questions, where we answer the questions on your radar.
Welcome into Weathered Questions, the podcast where we answer the meteorology questions on your radar. I'm meteorologist Kaj O'Mara, joined by meteorologist Jan Reichert, and of course, this podcast is all about your weather wonderings. We want to know what's on your radar. You can always email us the questions at weatheredquestions@gmail.com to join in on the conversation. Jan, it's summertime. We're right in the throes of it now.
Yeah, we are. It's been a tumultuous one so far. We've had some dry stretches. We've had some stormy stretches. I know I'm really enjoying getting outside for those warmer stretches, or maybe not warm. The comfortable stretches, we'll call them.
I'm good with comfortable stretches. It's been so humid, at least up in Iowa lately. So
it really has.
Definitely been interesting to watch it all evolve. But that kind of gets us into our first question. And this is going to come in from the city of Grimes, Iowa. This is Drew that's asking this question. So when it's not, storming and things like that, it's been hot. But when it is storming, Drew asks, why is it I'm hearing constant thunder rumbling, but not seeing lightning anywhere? Jan?
Yeah, so great question. A couple different things that could play into that. Generally, it's going to be that you just got too thick of clouds that's going to be blocking it. But another thing that's a little bit more complicated that could be playing into this is we've talked about this word before, a temperature inversion. And essentially what that is you've got a warmer layer of air aloft. And essentially that's kind of trapping the sound down near the surface. And so maybe there isn't a lot of thunder. Maybe there's, minimal thunder, but it's just kind of bouncing back around and around and around. And so you're hearing that same rumble over and over is what could be happening. So maybe it was only one lightning flash, but that thunder is still kind of constantly rumbling. And so that's what you're hearing. So it seems like there's a lot of lightning strikes that are creating multiple thunder rumbles. But really it's just the sound wave kind of hitting that inversion layer overhead and then bouncing around from that layer of air aloft down to the ground, back to the clouds, back to the inversion layer, back and around. And it just kind of bounces all around like a bouncy ball trapped in a small box.
That's a good way to think about it.
Yeah.
And so, thunder is a sound wave, effectively, is what it is. Mm-hmm. And if we just think about how sound travels and how sound operates, so we're going to go back to maybe those that are in high school and played an instrument in band, or maybe they were in the choir, or maybe they were in the orchestra. Or we can really date ourselves, or at least I'll, date myself. If anybody is a Dumb and Dumber fan, when they made the most annoying sound in the world in the van, and it was just this off-putting screech. So every one of these pitches has a different frequency. Now, there is a way, if you want, to try and do a small experiment with this. Let's just say, for example, you are around a pond that is totally still, and you had 5 people with you, and you all threw rocks of different sizes into the pond all at once. You're going to have different size waves. You're going to have waves moving at different speeds, and all of a sudden they get distorted, and these sound waves are crashing against clouds. They're crashing against the ground. Maybe they're reflecting back up. Maybe they're going off of buildings. And even though the lightning strikes, you might not see them because of the cloud cover, the sound waves are all over the place. Some are aiming down, some are going up, bouncing left and right. And so what you hear is this constant rumbling. And that's like that sound of rolling thunder. It might be a really, really distant lightning strike that was super powerful, but by the time the wave gets to you, it's so distorted. For any of the parents who really want to try this at your own house, if you have 2 instruments in your house, go have one of your kids play a B flat and the other one play a B natural, and let me know how you feel. Just see how those frequencies work with each other, and they'll go, just like that.
Yeah.
But that's pretty much the science behind it.
Do you want another fun sound wave science experiment?
Yes, please.
I just learned this one last week, 2 weeks ago. I got to go over to visit some friends in Omaha, and we went to the Luminarium, which is their science center there, basically, which again, not a sponsor or promoter or anything, but great spot if anybody needs a spot to go in Omaha. But they had an experiment that you could do where it was like a wire clothes hanger, like the kind you get from the dry cleaners or something that everybody has way too many of and you don't know what to do with them. Here's a use for them. Take that wire clothes hanger, and they had some string that they put on it. I'm not sure what kind of string it was. I think it was just a cotton string though. And so you tie the string, tie a close knot, and put two of those strings, so two separate strings that are probably about, a foot and a half long. Tie one to the kind of corner of the hanger, the bottom corner, tie the other one to the bottom corner. And then on the other end that's not tied to the hanger, a little loop that you can put your fingers through. And what you do is you put your fingers through those strings. So essentially you have the hanger hanging from two strings from your two fingers, and put your fingers in your ears and hit the hanger, like just kind of like nudge it against like the table, and you hear the sound wave through it, and it's just like that classic like boom.
Oh,
it is
interesting.
the coolest, like honestly, like as a 30-some adult, like it was kind of wild how cool it was actually. So for something so simple, just some cotton string and a metal clothes hanger, just kind of a cool sound wave experiment that you can hear the reverb from that hanger through your eardrums. It was really cool.
Sounds like a great home experiment for summertime when, parents might be lacking a good schedule that they had for a long time, and they just need to kill some time with something. That's a fantastic experiment. I was learning as you were saying that.
Like I said, I hadn't heard of that one before, and I loved it.
I was visualizing that in my head, which is why I was making so many weird faces at you. But nobody at home is going to see that.
I also had a fun personal experiment recently where I was on a Zoom call for work with several coworkers around the Des Moines metro area, and we had a loud crack of thunder, and I heard it. I kind of jumped in my seat a little bit from where I was, and teammates who were across town, didn't hear the thunder for 3, 4, 5 seconds later, and we had like 3 or 4 of us that were across Des Moines, and so we could report on when we heard the thunder. It was kind of wild and cool to have that happen in person too.
If there was a way you could stage that next time, and everybody do a stopwatch and just watch how the wave travels across town.
Yeah, that would be cool. We'll have to get something set up for next time. It'd be very STEM forward, so it would fit right into our talk, right?
Absolutely. Oh yeah. For sure.
All right. Well, so we've had some storms, but we've also had some other kinds of weather going on here. And Andrew from Urbandale is asking, he said he's seen a lot of videos of Europeans here for the World Cup, or people maybe who aren't normally in the US for the World Cup. And they're saying how different the weather is here. And he just kind of wanted to know what's so different about it. And he also said, kind of based on the videos, he thinks they're specifically talking about like the humidity and how they're like really hot and sweaty all the time. But like, why is the US maybe so much more different than Europe and what the Europeans may be normally experiencing?
Yeah. Well, I mean, if we think about the most basic sense, if Earth was a solid ball, I guess sphere technically, covered in the exact same type of grass. Yep. Covered in the exact same type of grass with no water anywhere, then Europe, being at the similar latitude as we are, should have almost identical weather because the same amount of sunlight would be striking it. The issue is it's not. It's actually much more temperate out there. They can have some really big heat waves though.
We hear about those, right?
But their winters, aren't nearly as ferocious as what we see over here. And their humidity wouldn't be as bad either for a couple reasons. Number one, they don't have nearly the cropland area that we do. But number two, think about what they're surrounded by over there. So in the United States, we have a cold Pacific Ocean way to our west, but really kind of specific to the Midwest area too. We've got Canada straight to the north. That is a dry, cold landmass. And Europe has ocean to the north and west. And so as Arctic air masses move over the ocean, we know that we're not seeing Arctic sea ice going clear down to 40 degrees north. We're not seeing that. So it does modify going across that water. And by the time it gets over there, cold fronts aren't nearly as bad. Same can also be said for that temperate type of ocean temperature that they've got. You're not going to see dew points of 80 plus all that often. It can still happen, but not nearly to the extent as what we are. So I think it comes down again to one of the points I've been trying to educate a lot of people on lately is, we don't want to totally forget about atmospheric composition, right? We don't want to totally forget about that. But land use is so important, not just the land you're on, but the land that's around you. It's why Miami is nice year round. It's why Casper, Wyoming, you're going to freeze if you don't get going up there. But there's, fun facts like Jacksonville, Florida versus Dallas, Texas. Who has a worse winter? Dallas by far, but not Jacksonville. Mm-hmm. So it depends on the land use. It depends on the water around you. And I think that's the big difference, really, between Europe and the United States is what's surrounding them. The latitudes are actually very similar. Certainly we're on the same hemisphere, as we know. And
in
the
fact,
weather
for
systems
much of
spin
Europe,
the same way.
Yeah, for much of Europe, they're further north, actually,
Yeah.
than, depending on what part of the country, what part of Europe, what part of the U.S. you're talking about.
Mm-hmm.
But if you're talking about, Kansas City versus London or Dublin or something like that, it is a lot further north, but you're surrounded by much more marine climate. And actually, that's something I kind of want to throw in. There's a thing that we as meteorologists use that's called the Köppen climate classification system. And if you want to, look that up, Koppen, Köppen. And it basically classifies all the land across the globe by, is it marine? Is it polar? Is it tropical? Is it dry? Temperate? All of those things based on all of this that we're talking about, where the, land around an area is what's mainly impacting it, and the water around the area, right? Not just the land, because as we've talked about before, and as is kind of common knowledge, even if you don't think you know it, think about it, it's harder to change the temperature of water, right? Just like Kai just said, Florida, much more mild maybe than a landlocked area of Texas that is at the same latitude. So things like that all play into why it might be a little bit more different. And then as for the humidity point there, we've talked about the Gulf of Mexico and how important that is to pumping moisture into the central parts of the U.S. And so again, that's right back at it, pumping moisture up through the Midwest in addition to all the crops and stuff too. So.
Yep. Yeah. Speaking of water content and heat, we see it in our microwaves every day. If you use a microwave, here's a great experiment. Take a cup of peas and a cup of baked beans.
Cup of peas, plural, not cup of pea.
Peas, yes. Let's say lima beans, just to make sure the FCC is good. Lima beans, they're drier. Baked beans, they're wetter. Put them on the same plate. Try and divide them somehow, but put them on the same plate. Microwave them, and at the end, figure out which one's warmer. And what winds up happening, this is the old Thanksgiving leftover debacle, where you've got mashed potatoes and something else, and it's like, well, those are going to probably have to go in an extra 30 seconds because there's more of it. It's more dense. It's got a lot more water to it. Same with our weather. Same with the ground.
It's a really good point.
And it gets us into a, totally derailed topic, but that's also why the summer solstice and the vernal equinox, despite having the same amount of daylight, are weather drastically different because the land is so different. One's coming out of a warm season, the other's coming out of a cold season. Simple as that.
Yeah.
Speaking of water, because we're talking about it a lot, we're going to talk about today's trivia question. And this is one of the first times, Jan, and maybe this is just because of internet hype. I don't know. A lot of times we hear about the whole La Nina, El Nino thing in wintertime. But I've been hearing a lot about it during the summer. And that's not necessarily as typical for us to hear about it. But when we are discussing something like this, your trivia question today is, when people reference El Nino, what part of the world is this talking about? Is it A, the Atlantic Ocean, B, the Pacific Ocean, C, the Arctic Ocean, or is it D, the Indian Ocean? We'll let you think about it for a few seconds, talk it out amongst yourselves, and we'll have the answer for you coming up. Alrighty, you got 4 possible water bodies on this one. When people reference El Nino, what part of the world is this talking about? Is it A, the Atlantic, B, the Pacific, C, the Arctic, or D, the Indian Ocean? Jan?
And maybe some people are already like, whoa, like I didn't even know where El Nino referred to an ocean. So we gave you that one, right? Like
that's true.
El Nino is specific to a body of water. And we'll kind of talk about everything that goes into it here in a second. But I mean, I know the answer. Do you want me to give it away?
Go ahead.
Okay, right.
Go ahead.
I'm not
I know it too.
So it's going to be the Pacific Ocean. That big giant body of water that's off to the west coast of the U.S., North America, South America, and to the east of Asia and Australia. That's where El Nino originates. It's something we call in meteorology a teleconnection. And essentially, that's a big fancy word for it's something that happens. Again, we'll get into the nitty gritty of it here, but it happens in the ocean there in the Pacific Ocean, and it influences weather elsewhere. So that's kind of where that teleconnection term comes from.
Yeah, it kind of just kicks a signal down the road that this is kind of what I want this pattern to do. Think about it as it's just a warm or cool feature within that body of water. It typically narrows right up along the equator, or just south of there. So what happens in an El Nino situation is when that water is a little bit warmer than normal, it doesn't need to be by much. A degree or 2 Celsius is typically, that threshold. So yeah, it doesn't, when we go outside and play a golf game, it doesn't really matter. But if you're talking about water temperature, it does matter. And what can happen
back to the whole it's harder to change the temperature of water conversation that we just had.
And what happens, it takes a lot of heat to do that. It takes a whole lot of heat to do that, to change that amount of water. Now, granted, it's just surface water, because then if it upwells and brings cool water in from below and it cools everything, well, now you're in a La Nina pattern, which is opposite. But what can happen is the jet stream can do some funny things. And it can kind of get into a semi-permanent type of pattern for a while, but there's always going to be some variation in it. And the thing about El Nino, it's about an every 2 to 4 year cycle. Some years it sticks around a couple years, but in most cases it's just generally a natural variable cycle that about every 2 to 4, every 2 to 5 years, it's going to flop back and forth from neutral to warm to cool. And a lot of our effects in North America are more profound in the cold season. Whereas the warm season, it just doesn't seem like the connection is quite as strong as it could be.
Yeah. And we're not in an El Nino right now. We are
going into one, but we're not
leading
in it yet.
Into one, yes.
Right.
Which basically is that conditions appear favorable, that we are turning toward that warming that Kai just mentioned, and that we will get to the threshold of officially being in an El Nino. And so maybe that's why we're hearing more about it right now, is just that we're kind of leading into it and people are anticipating what's going to happen. I wouldn't be surprised also if part of it is just that we are seeing more extreme weather, given,
could be
more of those droughts, more of those floods, more of those, extreme storms. And then we get the opposite too. And so I think maybe people are just a little more sensitive to it. I wouldn't be surprised if that's part of the reasoning, but yeah, it's definitely a interesting thing. And in fact, I just had a conversation with a coworker here. This question comes in from Reese in Altoona, and he said, I've been hearing a lot about El Nino and rain. So is it actually going to be a wet summer? What's actually happening here, Kai? We just talked about, obviously, that it's not actually El Nino yet.
Right. Yeah. And so the best way I can answer this question, I actually did, I looked it up for a totally different reason several days ago, but it wasn't necessarily for this reason. So I can thankfully multi-purpose this data. But if you go to the Climate Prediction Center, it's kind of buried within their website. They've got what's called an ENSO history, which is El Nino Southern Oscillation is what this is called. There's a history there that goes back to 1950. and they've got various positive or negatives that they put in there. El Ninos are positive, neutrals are 0, La Ninas are negative. And so if you go back and you kind of look, all right, how does it really look with an incoming El Nino of this strength? And what I had to also do is figure out, all right, a lot of these folks, even the climate folks, are saying, all right, yeah, this could be like a +2 kind of El Nino. That's a significant one. And we only have a few of those on our records, at least since 1950. We know it's been around a lot longer than that, but at least reliably, that's the best I could find. In those years, we weren't as hot in the upper Midwest, but we were humid as heck, and we did have a fair amount of rain. So, and that was also true in the Northern Plains. I bounced this off of a coworker, and he found the same similar trends in the Dakotas and Western Nebraska too. So let's just see if that holds. Now, for the rest of the country, it was hotter down south. So you have to wonder if it's going to be like a Texas blazing type of summer. I don't know. But when we only have a few good sets to work with, that increases variability. So based on how the summer has started in the Midwest, I would think that humid and a little bit wetter could be a thing. But we also just saw, for some folks, a 2-week dry stretch that happened. So sometimes those long dry stretches can get you into flash drought just like that. And so that might be another thing we got to watch for this summer.
And I think another important thing to throw in here is El Nino isn't like this big overarching,
right,
weather controller. Everything else is still at play here too, right? We're still dealing with all the other normal players in the weather forecasting game that could still influence either storms or lack thereof. So yeah, there's a lot of different things that could push our weather any one way. But if you're specifically looking at El Nino and what could happen, that it could lean slightly wetter, but it's not necessarily a guarantee.
Right, exactly. Well, and we kind of hope it does for portions of the area. We'll touch on this real quick before we wrap our episode up. This actually came to our email inbox. Reminder, you can ask us questions anytime you like. weatheredquestions@gmail.com to join the conversation. Ed wrote in with this question. Hello, there is growing drought, especially east of the Mississippi, now taking shape in Iowa, due to persistent blocking from the Great Lakes. How long do you think this pattern will hold? Thanks. Jan, what do you think? It's a tough question to ask right now. It's
it
tough.
really is. It really is, right? And how long do you think that pattern will hold? Well, we did kind of just allude to how El Nino may give us a little bit wetter weather and some more weather. I do think also that we are leading into, one, we've been having some decent rainfall, at least in Iowa. But kind of looking through the Drought Monitor, the U.S. Drought Monitor, which is a fantastic resource and a great website as well that is open to anyone. They do have a feature on there where you can compare time frames. And we have been actually kind of relaxing that drought back pretty substantially here over the last short while. So that's been
it's a good thing for sure.
Exactly. That's been nice to see as well. Definitely. Sorry, I'm still kind of thumbing through it a little bit. It definitely, as with everything, weather will kind of ebb and flow, but I would say down in the southeastern parts of the U.S. is somewhere that has been kind of worsening, and then off well into the Great Plains. But fortunately, Iowa is really honestly looking pretty good at this point, and not too much of a concern for us right now as we go into the peak of the growing season. But it just really depends if we do continue to get that rainfall. And as far as meteorology goes, it's just really tough to tell. As far as the climatology of it goes, those long-term trends, things are hopefully going to be on the wetter side as we move forward.
If we can, we'd like to do 1 inch to 1.5 inches a week just to keep up with crop demand. If at all possible, from now through mid-September, roughly. That's the general amount of water we would want. I can tell you one thing before we close quick. I did do some research when we were together on TV, and it's kind of like the faucet's either on or the faucet's off. To the point of the extreme weather you were talking about, even if the year looks normal from a calendar perspective, the amount of 7+ day consecutive day dry stretches seems to be going up over time. meaning when it rains, but when it's dry, it's frustrating. Like it's 10 days, it's 14 days with no rain. Like a great example was from mid-May to the first week of June, I picked up less than an inch of rain. Last couple days I've been hit hard. So that kind of just puts it right in perspective, that it seems like the frequency of these prolonged dry stretches are increasing, but hopefully it can happen. Hopefully the rain can happen regularly enough that we don't see a whole lot of crop impact on it, but it's early. We'll see.
Yeah.
There's long
And I would
go.
agree. I would agree with all that. I think that's exactly what we're observing, and that plays right into climate science and exactly what has been anticipated with a warmer climate. Exactly what we'd expect is those bigger stretches and those wider extremes. So, definitely all expected. Well, that brings us to the end of another episode. So thank you again for listening, for spending your time with us here today. If you learned something, if you enjoyed the conversation, feel free to leave us a review. Tell your friends and family. Those are the best ways to support the show and let us know that you still want weathered questions around. And we greatly appreciate it. If you have questions of your own or just want to shoot us an email, hey, we're around, we're listening. Weathered Questions, again, that's with an ED at the end of weather, weatheredquestions@gmail.com. We want to know what's on your radar, and we hope you stay safe until next time.